In this lesson, we're going to start to focus on how to calculate measures of central tendency. This video includes instructions for the TI-nSpire series of calculator. We'll focus on measures of central tendency in a variety of contexts, but our main goals are to learn how to calculate these measures of central tendency for discrete and continuous data, and also to establish the reliability of these measures of central tendency. But first, we should clarify what we mean by measures of central tendency. You're likely familiar with all three already. We're going to talk about the median, the mean, and the mode. Measures of central tendency help us to analyze and understand what's going on within the center of a data set. To calculate the mean of a data set, we take the sum of all of the data and divide it by the total number of data. This is what's commonly referred to as the average, even though in reality all three measures of central tendency are averages. We call the mean of a sample x bar, and we calculate it by taking all of the values, summing them together, and dividing them by n. N represents the total number of data in a data set. Most mathematicians will consolidate this notation by expressing the sum of all the data using sigma notation, as you can see here. This is the same notation we used when we were studying discrete functions earlier in the year, talking about sequences and series. The median value of a data set is the middle value of the data set when it's been put in ascending order. If the total number of data is odd, then finding the median is very simple. Once you have an ordered list, it's quite literally just the middle element of that list that represents the median of the data set. In the scenario where the number of data is even, we have a little bit more work to do to find the median. Because there is no clear middle value, what we actually have to do is take the two middlemost values and average them. So add them together and divide by 2. The mode is a measure of central tendency we looked at last time. With discrete data, it's the most frequently occurring value, and with continuous data, it's the class interval that has the highest frequency of data in it. Let's take a look at finding our measures of central tendency by hand with a fairly small data set. Typically, if we're calculating measures of central tendency by hand, we're actually going to want to order the data set first. Now that we can consult the ordered data set, finding the median and the mode will be very straightforward. The value in the 5th and 6th positions of the list, respectively, are 4 and 6. And because there's an even number of data, I'll have to average those out to find the median, which is 5. With the data written in order, it's also a lot easier now to see that the mode for this data set is 8. The mean requires a little bit more work. I'll need to take all of the data values, add them up, and divide by 10, which is the total number of data. When I calculate this value, I get a mean of 5.2. All in all, completing that exercise by hand wasn't too challenging. The data set was fairly small, though. If we were doing this in a real application setting, our data set would likely be many orders of magnitude larger. And so we're actually going to need to learn how to use technology to compute our measures of central tendency. To practice doing this with our calculators, we're going to use the randomly generated number set that was used in our last video. Get out your TI-nSpire calculators to follow along now. We'll need to begin by adding in a List and Spreadsheet tab to our document or scratchpad, and we're going to enter all of the data into one of the columns here. The data does not need to be written in order. The calculator will handle that for us, but we do need to make sure that we are careful about entering in all the data exactly without missing any values or entering in anything incorrectly. To make our data easier to access in other parts of our calculator, we'll want to go up to the header and add in a name for the data set. Once we've done that, we can access our analytical tools. Press the menu button and select 4 to get to the statistics menu. Select 1 to get to stat calculations and 1 again to access our one variable statistics option. We're only using one list, so click OK. And then when it asks you for your data, select from the drop-down menu the named data set that we created, and then click OK. Our spreadsheet has now been populated with some one variable statistics. You can see x bar at the top, which is your mean, and as you scroll down, you'll also find the median of your data set has been calculated for you. This information will always be stored in the spreadsheet right alongside your data set. Our calculators can determine these values far more efficiently than we could by hand, which makes them indispensable tools when it comes to analyzing data for statistical purposes. So we now have our mean and median for the data set. When calculating our mode, we'll need to do that by inspection, but we can see that 2 is the most frequently occurring number in this data set, so that will be the mode value here. In our discussion of different types of data, we brought up the issue of skew and data sets being skewed in one direction or another. Now that we have some statistical measures at our disposal, we can actually look at the notion of skew with a little bit more clarity. We will do that by considering two data sets that are very closely related to each other. The first is a list of 5 numbers, 1, 4, 6, 7, and 7. If I calculate the measures of central tendency here, I find that the mean of the data set is 5, the median is 6, and the mode is 7. I'll now consider a second data set, nearly identical to the first, except that we've added one extra value, the number 100. If I were to determine the median and the mode for this data set, we'll notice that not much has changed. The median has shifted slightly to 6.5, and the mode of the data set is still 7. However, when I determine the mean of the data set, I see that it has skyrocketed up to 20.8 approximately. There's a significant shift here due to the addition of the number 100 to the dataset. What this is meant to illustrate is the reliability of our different measures of central tendency. In the presence of a large outlier, like 100 in the second dataset, the median and the mode are largely unaffected. The median shifts slightly, the mode remains unchanged. However, the mean is very susceptible to influence from outliers, and so the presence of that one outlier has skewed the mean of that dataset, so it's now more than 4 times larger than the previous dataset, just from the presence of one value. So the median and mode tend to resist the influence of outliers. They tend to always give a reliable measure of center without being twisted about by extreme values. The mean, on the other hand, is very susceptible to those extreme values, and as soon as they're introduced to a data set, the mean might fluctuate wildly and skew the data in one direction or another. This isn't to suggest that the mean is not a useful measure of central tendency. If anything, all 3 of these measures are useful in different contexts. It's important as a statistician for you to recognize which measures of central tendency are appropriate given the circumstances, and you do need to be mindful of how some can be skewed and others are more likely to resist being skewed. You should now be well equipped to determine measures of central tendency from an unordered, discrete data set. We'll dig deeper into continuous data in a subsequent video. We've also established the reliability of different measures of central tendency, and this is something you should be mindful of as you do calculations in statistics.